We did 4.1 vocabulary notes, right? What you can use on the quiz, probably, I'm thinking more Friday. And then we did 4.2 vocabulary that you can do, have on the quiz on probably Friday. Then we did the first page of quadratic modeling, did we not? Okay, we need to continue, bless you. We need to continue with quadratic modeling, right? Okay, dokie, let's continue. Language. Language. Okay. Number 3. You are playing basketball in a European league. So remember, we are going to use metric. You release the ball at a height of 1.9 meters. What would that be in our formula? The height, what height? The total height or the starting height? Initial height. So this is going to be our initial height, h of 0. It says, with an initial velocity, get away from there. Go sit down. No more drawing penises on my board. Go sit down. You juvenile. Okay, with an initial velocity of 8.1. So there's our v sub 0. How many seconds? So we're looking for s of t, right? How many seconds until it reaches the rim, which is 3.05 meters high? Now, we're doing seconds, so s of t. We are not using negative 16 because that's standard gravity measurement. We need to use metric gravity measurement, which is negative 9.8. We're looking for the time t squared plus our initial velocity, 8.1, t plus our initial height, which is 1.9 meters. So there's our equation. There's our parabola, our quadratic function. Okay, let's make a sketch. Sketch to help us brainstorm this. Okay, here's my y-axis or my height. Here's my x-axis or my time. Okay, our initial height. Knock it off. Our initial height is 1.9 meters. What do you think that's representing? The guy's standing up, right? Ready to shoot. Okay, that's our initial height. So he shoots, bam, hits the rim, goes through, and it drops to the floor, right? Okay, so this is our rim, right there. And language. And we know the height of the rim, right? They give it to us, 3.05 meters. So that's our vertex. Our maximum vertex is 3.05 meters. And we're supposed to find how long it took to get to this point. That's my t time. Does that make sense? Okay. What are we gonna do now? What do we need to? Yeah, I'm going to put it in my calculator, right? Grab your calculators. I'm going to put it in my y equals and graph my parabola. So negative 9.8x squared, oops, plus 8.1x plus 1.9, graph it, and it's really kind of small for me to get any numbers off of this. So I'm gonna mess with that window again. Okay. I don't need so much of this negative stuff down here, so that's my y negative 10 window. So let's change that first. So y min negative 10, I'm going to change that maybe to, I don't know, let's try negative 2. Let's see what happens. Good, it kind of moved it up. Now I want to zoom in. I don't need all this extra y max here. It looks like, well, we know what that is. It's 3.05. So I'm going to set my y max to 4. Okay, back to my window. My y max, I'm going to set at 4. And now let's look at our graph. That's pretty good. I wouldn't mind stretching this out. I only need my x max to go to, looks like 1 or 2 here. Maybe I'll put my x max to 3. I definitely don't need all this negative x. So let's get rid of that. Negative 1. I might just move this up to like 5. Graph. Yep, that looks pretty good. So you're going to have to learn to mess with the window on the quiz and the test. This is on your final test. Both of them. Both of them. Both of your finals. This is a big part of it. Okay? All right. So I need to find language. I need to find that vertex again. That's our maximum, right? I need that t value there for my time. Does everybody remember how to do this? Second, trace. We're looking for the maximum this time, not the intercept. Hit enter. Left bound. I need to be to the left of that point. So I'm going to hit enter. Right bound, I need to be to the right of the vertex. Hit enter and enter again. And my x value is 0.413. So the time it takes to shoot this basketball to the rim is 0.413 seconds. Now, when I first did this problem, I'm like, wow, something's wrong, right? A half a second seems a little quick, doesn't it? But then I went back and breathed it on my calculator like 3 or 4 times and still kept getting the same answer. I'm like, well, let me try a different way to get the x coordinate of the vertex. How do I get the x coordinate of a vertex in standard form? I'm going to tell you. Even though you know this because we spent the last 3 days on this. It's negative b over 2a. Okay. Well, look at my formula here, my equation. Negative b, my b is 8.1 all over 2 times my a, which is negative 9.8. Okay, negative is going to make it a positive, so I have positive 8.1 over, let's see, 16, 18, 19.6. And 18 or 8.1 divided by 19.6 gives me 0.413265. And guess what? It's the same answer. So I know with 100% guarantee that it is indeed 0.413 seconds. Stupendous, right? These are getting so easy for you. It's like you almost don't have to do your homework. I said almost. Then it says your calculator can also help you solve some non-real world problems as well. Oh, any questions on this? For those of you who are paying attention. Yes, ma'am. You have to mess with it, okay? Actually, you just push this button, window button, and actually, if you hit zoom number 6, zoom standard, it brings everything back to default. Okay. I just play with it. I know that on my y-axis here, I know the highest that it's going to be here is 3.05. It might be a little off with the rounding issues in your calculator. So I did a maximum. I definitely know it's not going to go above 4. So that's why I put on your y max. Cut them in. Why? On my y max, see how it's 10 here? I just put 4. So it's just going to cropping the picture, what I'm doing. Okay. So I just want to go a little bit forward. Remember yesterday we had 120? So I put like 140 there to crop in the whole thing. And then I know that this intercept was somewhere around 1. This is my x-axis. This is my x maximum because it's positive infinity. So I put in like, number 4 there. Or actually, I think I put in 5, but let's put in 4. I don't need this much negative. In fact, I don't need any negative y or negative x. So I could even go to like, for my minimum, for my x and y, -1, and then my y's, I don't need any negatives there. So I can put like -1 there. I'm doing that all through that window button. Okay. Now when I graph, see how I get a nice cropped picture of the parabola. It's just something you're going to have to get used to. Okay. Takes practice. Yes, Victor. There's 0.413. I found out the x value of the vertex. This is a maximum, right? Because it's the highest point. If my parabola went up, I would be looking for the minimum. But this is a max, so I did second trace. I'm looking for the max, hit enter, and I have to do that whole left bound, right bound thing again. Now, I can't find my cursor, right? I'm looking for my cursor. It's probably happened to you on your calculator. My cursor right now is at 1.5, -8. Well, that's way down here somewhere. Okay, so I'm going to bring my cursor back up to real close to under 1 because it looks like it's crossing here at 1. Or, I'm sorry, we're looking for the maximum. So it needs to be like my x needs to be less than 1/2. So I'm going to watch it here as I use my left one, see how that's getting smaller and smaller and smaller. Left key, smaller. And there's my cursor. Okay, I want it to at least under 1/2. And here I got 0.36. So that works for me for my left bound. I'm going to hit enter, get to the right of that vertex, hit enter. So I know it's in between those two. Then hit enter again, and that's how I got that 0.413. Okay, that's what my T is. Okay, the x coordinate of the vertex. Any other questions? Okay, let's do number 4 then. And there's a lot of different ways of doing this. Okay, area of a rectangle. You guys did quite a bit of this in Algebra 1 and geometry. Okay, it says here the area of a rectangle is shown as 105 meters squared. Find the value of x and the dimensions of the rectangle. Well, what's the formula for area of a rectangle? Length times width, right? So my area, they give us the 105 equals my length, 2x plus 1, and I'm going to multiply that by my width, x. So there's my quadratic function. I'm going to put it in standard form, okay? Which means I have to get a y or a 0 on this side, everything else on this side. So, first thing I'm going to do, distribute that x. So I get 105 equals 2x squared plus 1 times x is just x. And I need to get my 0 on this side so I can plug it in my calculator. So I'm going to subtract 105 from both sides. Okay. That gives me my 0 over here. And my quadratic function then in standard form, 2x squared plus x minus 105. Okay. So I'm going to plug that into my calculator. Okay, I'm going to go back to my window, or I'm sorry, go to Zoom Standard, give me my default graph. Then in my y equals key, I'm going to put in my quadratic function, 2x squared plus x minus 105. I'm going to graph it. So my parabola is off the calculator, but I'm okay with that, with this one. I need this intercept because that's going to tell me the positive x value. This is going to be a negative x value. I don't care about that because I'm working with distance. So I need the positive x. So I need to find the 0 or the x-intercept for this. So I'm going to go to second, trace. I need to find the 0 and enter. Now here it is again. My cursor is not on the screen. But if I look here, my cursor is at x equals 0, y equals negative 105. So I want to get my, this looks to be at 1, 2, 3, 4, 5, 6, 7. So I want to get my x close to 7. So I'm going to use my right arrow key. See how now it's increasing? I want to get it close to 7 so I can see my cursor. Oh, there it is. Okay. To the left of that point, it's asking me left bound. I'm going to hit enter. Now I want to get to the right of that, so I got to go above the line, hit enter, and enter again, and my x happens to be 7. Okay? My x is 7. My length is 2x plus 1. I plug in 7 for my x. I get 14 plus 1, which is 15. My width equals x, which just equals 7. So there's my dimensions. All right, you've got some homework to do. On the bookwork, okay, on the bookwork, you got page 199, number 39. And This looks okay. I'm okay. I think you guys can do this one. Page 207, number 38. Page 207, number 38. This is one that, like the last problem we did, if you want to try this, go ahead. If you get stuck with it, don't worry about it. We'll go over it in class. Okay. So 38, oh, just put a question mark there. 43 you should have no problem with. Page 39, number 59. Page 231, 59. Again, you should not have any problems with this because it's in the form we've been doing. That's good. Page 245, 37. Number 37 looks good. Guys in the room. Number 38. This looks okay. And 56, I did not put on the page for you, so you don't have to do 56. So there's your assignment. Questions, comments, concerns? All right, go to it. If you have any problems, raise your hand.